What you're seeing here is the training data for a student Pac-Man project. They played a simplified version of Pac-Man in Scratch, but they'd set the game up in Scratch so that every time they pressed one of the arrow keys to go left or right or up or down, as well as moving their Pac-Man character, that put the XY coordinates for Pac-Man and the XY coordinates for the ghost into the training bucket for that direction. So for example, when Pac-Man was at the XY coordinates 4, 3, and the ghost was at the XY coordinates 9, 7, they pressed the arrow key to go left. So that became a training example for when it's a good example to go left. And they used all of these training examples to train their own machine learning model to be able to play the game. A machine learning model that can predict when Pac-Man should go left or right or up or down, based on the current location of Pac-Man and the current location of the ghost. And the goal is to be able to train the game so that Pac-Man can play itself without them having to touch the keys at all. Now, some students will often be impatient. They're going to be eager to try out their model as soon as they can, so they will start putting the machine learning model in charge of the Pac-Man character before they've collected many examples. And with only a few training examples, their Pac-Man might not have even learned enough to navigate the maze, and it can get stuck in the corner or stuck against the wall. So they have to go back and do a bit more training, collect more examples of them playing. With a few more examples, they start to see their Pac-Man doing better. They start to see their Pac-Man able to navigate the maze, but maybe it still gets caught by the ghost very, very quickly. So they go back and do even more training. They collect even more examples. Like you can see here, where they've got dozens and dozens of examples of when it was a good idea to go left, right, up, or down. So they train a new machine learning model with a large number of examples, and they see their Pac-Man start to do well, start to do better. Some of the students will even see their Pac-Man able to evade the ghost forever, always one step ahead, always able to keep away from the ghost. What the students are stumbling onto for themselves is the correlation between the amount of training data and the accuracy of a machine learning model. This is a crucial principle in applying machine learning technologies, but instead of me telling them that as a rule, students discover it for themselves through experimenting, through observing the performance of their own machine learning model. They notice for themselves how their Pac-Man improves as they add more and more training examples. Giving students the freedom to experiment with their machine learning model lets them learn for themselves about the relationship between the quantity of training data and the accuracy of a machine learning model.